In this lesson, we will graph linear equations in two variables. The goals of this lesson are to graph the equation of a line given the equation in slope-intercept form, given a graph to write the equation of a line in slope-intercept form, to find x and y intercepts given an equation in standard form, to find the slope of a line given the equation in standard form, and to determine if a point lies on the line of an equation in standard form. In the first example, we talk about definitions of x and y intercepts. An x-intercept is the coordinate of a point where the line intersects the x-axis. An example of this is listed right here. This would have an intercept at 1, 2, 3, 4. Or 4, 0. A y-intercept is the coordinate of a point where the line intersects the y-axis. An example of that is right here. So this point right here would be at 0, negative 1, 2, 3, 4, 5. We also want to remember that the slope is equal to the rise over the run, or in other words, the vertical change over the horizontal change. In these four examples at the bottom, we want to think about what a positive, negative, 0, and an undefined slope looks like. We're always going to read each of these graphs from left to right. So when we talk about a positive slope, from the left to the right, it's got to increase. So here's an example of a positive slope. A negative slope, when we go from left to right, is going to have to decrease. A 0 slope is going to go straight across horizontally. And an undefined slope is going to be a vertical line. I always think about skiing when I look at these different types of slopes here. 3 of these are actually considered slopes. And I remember that you could ski on all 3 of these types of slope. This one, sure, it's pretty steep, but we can ski on that. Same thing here. Even this one would work because it would be considered like cross-country skiing. However, if we got to the undefined one, this is a cliff that we would fall straight down off of. So this one is not really a slope. This is our special situation. We also want to remember that slope-intercept form is y equals mx plus b, where m represents the slope and b represents the y-intercept. When we graph, we're going to start by plotting the y-intercept, the b value. From there, we're going to use the slope to find another point. We're then going to connect the points with a straight edge, making a solid line throughout the graph. So in our first example, we identify that our slope here is 3 and our y-intercept is negative 4. So we're going to start with the y-intercept of negative 4 and we plot that. Once plotted, we're going to go ahead and take care of the slope. So again, it's increasing as we move from left to right. It's got to go up 3 units to go over 1 unit, and we make a point. You could continue to do this throughout the graph, and you should if you don't use a straight edge. If you are using a straight edge, you can go ahead and connect those lines. For number 2, we'll follow the same steps. Start by identifying the y-intercept, which is 2, and plotting that. Here the slope is negative, so from left to right it should be decreasing. So that negative can either go at the top or at the bottom, but definitely not both. Here what I'll do is go down 1 unit to go to the right in the positive direction 5 units and make a point. Again, if I'm not using a straight edge, I'm going to continue making points, and I could even work on points this way if I go up 1 and then back 5. Again, knowing that that negative can go with either of those. I connect them using a straight edge. That's what my line should look like. For number 3, this is an x equals negative 2. Right away, we should notice that this doesn't say y equals. So it's going to be our undefined slope. And what we do know is that it crosses at negative 2, and that's that point right there. That's where it crosses the x-axis, and it's going to be a vertical line. So anytime you have just x equal to a number, it's going to be vertical. For number 4, we again want to start with our value for b. Well, we don't have one listed here. So since there's nothing listed there, hopefully we realize that that's a 0. So I'll plot that at 0. Our slope then is positive, so I'm going to go up 1 unit to go to the right 4 units and make my point. Connect using a straight edge, and that's the equation of that line. Now we're going to do the opposite, so we're going to write the equation of a line. In this example, if I identify the y-intercept, it's going to be at negative 2. It is also a positive slope. I want to identify a second nice point. That's going to be where our line is intersecting perfectly with two grid lines. And so to go from this point to this point, I'm going to go up 1, 2, 3 units, to the right 2 units, giving me a slope of 3/2. And therefore our equation ends up being y is equal to 3/2 x minus 2. For number 2, I see right away this is a horizontal line. A horizontal line is going to be y equals a number, and it's whatever number where it crosses the y-axis. In this case, it's at 1, 2, 3. So our answer for number 2 is y is equal to 3. Now, another way to think about this is it goes up none to go over 2 units. So since our rise is 0 and it goes over 2, 0 divided by 2 would still just give me 0. Now, if you wrote this as y equals 0x plus 3, it would be considered correct, but it is unnecessary, and y equals 3 is the better answer. For number 3, writing this equation of the line. Again, vertical line is going to be x equals a number. That point is back at -1, 2, 3, 4, 5. So we're just going to get x is equal to -5. If I were to come up with the slope here, it does look like it rises 1, 2, 3 units to go over none. So 3 divided by 0, we're not allowed to divide by 0, which means, again, it's going to be an undefined slope. So our answer ends up being x is equal to -5. For number 4, we identify b, which is right here. It's also a negative slope. I find another nice point. It's going down 1 to go over 1, 2, 3, 4. So that slope is -1/4. Our answer ends up being y is equal to -1/4 x plus 6.